Hi everyone, in this video, I'm going to demonstrate experiment 4 linear momentum.
At the end of this video, students should be able to verify the principle of conservation of linear momentum. Linear momentum P is a vector quantity defined as the product of mass m and velocity v. For a body of mass m and velocity v, its momentum is given as P equals to mv. In the absence of external force, the total momentum of the system is conserved, and this is known as the principle of conservation of linear momentum. In this experiment, we shall study the oblique collision between two ball bearings on a curved track. The first ball bearing is released from the top of the track so that it gains momentum m1u1 before it hits the second ball bearing, which is stationary. Let m1 and m2 are the masses of the two colliding bodies, and u1, u2, v1 and v2 are the velocities of the bodies before and after the collision. By applying the principle of conservation of linear momentum in collision, the total momentum of the colliding bodies remain the same before and after the collision as shown in equation 4.1. Since momentum is a vector quantity, the principle of conservation of linear momentum is equally true in both x and y axis direction. In the case of an oblique impact, we resolve the momentum into x and y axis respectively and retain as shown in equation 4.2 and equation 4.3. Let h be the height of the ball bearing 1 from the falling point to the ground when it starts to fall freely, and r is its horizontal displacement. If t is the time of flight, then from the kinematics equation, sy equals to uyt plus half ayt squared, we will get t equals to square root 2h over g. The horizontal displacement of the ball bearing will be given as r equals to uxt, where u equals to r square root g over 2h. Evidently, the velocity of the ball bearing is directly proportional to its horizontal displacement r. Since the ball falls from the same height, by substituting equation 4.4 into equation 4.2 and 4.3 respectively, we can verify that this principle of conservation of linear momentum.
The apparatus required for this experiment are level table, curved track, two ball bearings, pendulum box with a string, meter roll, 4 pieces of drawing paper, 4 pieces of carbon paper, electronic balance, and cellophane tape.
Now, we will proceed to the procedure of this experiment. Step A. Weigh the mass of the two ball bearings by using the electronic balance. Record the mass of the two ball bearings in data observation.
Step B. Now, we will set up the apparatus as figure 4.2a. Place the track on the table, whereby the end of the track must be exactly at the edge of the table and horizontal. Attach the string and the pendulum bob at the end of the track. Step C. Mark a fixed point A on the curved track. Step D. Release ball bearing 1 from point A.
Observe the landing point of ball bearing 1 on the floor in order to place the carbon paper.
Step E. Place the carbon paper on top of a drawing paper and then paste on the floor where the ball bearing 1 landed. Step F. Release ball bearing 1 from point A and measure the distance from the bottom end of the pendulum bob to the landing point of ball bearing 1 x0. Repeat this step to obtain at least 5 readings and calculate the average value of x0. Draw a reference line from the pendulum bob to the landing point of ball bearing 1. G. Place ball bearing 2 on the end of the horizontal track slightly off the path of ball bearing 1 so that an oblique collision occurs. Step H. Release ball bearing 1 from point A. These two ball bearings will subsequently collide and fall freely in a projectile motion. Step I. Measure the position of landing points for each ball bearing, that is x1, y1 for ball bearing 1 and x2, y2 for ball bearing 2.
So student, what you have to do next is tabulate your data. For data observation, you have to repeat step G to I for at least 4 times. Determine whether your results satisfy the equations 4.5 and 4.6 and give your comments.
Next, write a full report. Verify the principle of conservation of linear momentum. State the source of error and precaution. Lastly, write your conclusion for this experiment. That's all for this video. Thank you for watching.